Right, so let us see this question. Now this question is very similar to the 8th question which we have solved above. Now let us see what it is saying. It is saying that a thin prism of angle 6 degree, that means A is equals to 6 degree, and omega is given to us. Omega is 0.07, right, and mu y is equals to 1.5. So it is combined with another prism having omega dash for the second one, for the second prism, omega dash would be equal to 0.08 and mu y would be equal to 1.6. Now the combination produces no deviation in the mean ray. A part, find the angle of the second prism, right? So first of all, let us see. So if omega is given, I know the formula that it would be mu y minus mu v minus mu r divided by of mu y minus 1. So from this I can get the value of mu v minus mu r, which would be equal to 0.5 into 0.07. So this would be equal to 0.035, right? Similarly, I can get the value of mu v dash minus mu dash for the second prism, right? So which would be equal to 0.6 into 0.08, which would be equal to 0.048, right? So we got these two values. Now since we have to calculate the angle of the prism where there is no deviation, now the net deviation delta is given by A into of, what is the deviation? Mu y minus 1 plus A dash into mu y dash minus 1. This is the deviation. Now this has to be 0. So this implies that A is what? 6 degree into of mu y minus 1, which will be equal to 0.5 plus of A dash into 0.6, which would be equal to 0. That means A dash would be equal to minus of 5 degree. Now minus shows that the other glass has to be inverted, and this shows that negative is inverted prism, right? The other prism is inverted, right? And it is having an angle of 5 degree, right? So we got the first answer. The second, find the net dispersion produced by the combination when a beam of white light passes through it. Now what is the dispersion? Dispersion is given by A into mu v minus mu r plus of A dash into mu v dash minus mu r dash, right? So this, which would be equal to 6 into mu v minus mu r, we calculated 0.035 minus of A was minus 5 degree, minus 5 of 0.048, right, which would be equal to 0.21 minus 0.24. So this would be equal to minus of 0.03, right? So this is the net angular dispersion, right? Now if you move on to the C part, what it is saying that if the prisms are similarly directed, that means we have inverted this prism. Now the two prisms are like this only, right? Similarly directed. What will be the deviation in the mean ray? Now delta would be now given by A into mu y minus 1, similar formula which we have used in the first part, A dash into mu y dash minus 1. Now here mu A dash we would use plus 5, right? So 6 into 0.5 plus 5 into 0.6, right? So this will come out to be 0.6. Sorry, this would come out to be 6. So deviation will be 6 degrees. Now if I talk about the D part, it is saying find the angular dispersion in the situation described in C. So again, using the same formula which we have used in B, we'll just invert the minus sign, and we will use the dispersion would be 0.035 into 6 plus of 5 into 0.048, which would be equal to 0.21 plus 0.24, right? So this would be equal to 0.45 degree, right? So this would be the answer.